All right, the coordinate plane, otherwise known as the Cartesian coordinate plane or Cartesian coordinate system, which is named after the person who is thought to have discovered it, René Descartes, a French philosopher and mathematician. And it is said that he came up with it in a dream. All right, so it's a two-dimensional system. It has an x-axis, the horizontal axis, and a y-axis. And any point on the coordinate plane can be located by its unique ordered pair. Unique in math is a very specific meaning. It means there's one and only one. So every point on this plane has an address. So for example, the address for this point is its x-coordinate and y-coordinate. So this would be the point 3, 2. And you may be wondering what these Roman numerals are. Those are the quadrants. So the quadrant where x and y are both positive is the first quadrant. And we go counterclockwise. The second quadrant is here. This is the third and fourth. So you could just take a moment and practice writing down the Cartesian address for these points. If you want, you can hit the pause button and practice. All right. So for this point, you go 1, 2, 3, 4 for the x, -1, -2 for the y. You write the x coordinate first and the y coordinate second. For this one, the x, -1, 2, 3, 4, -5 is the x coordinate. And the y coordinate is 1, 2. The x coordinate for this point is -3 in the x and -4 in the y. And the point at the very center has the ordered pair 0, 0, and it's often called the origin. All right, now let's talk about the midpoint formula. So first, let's do the midpoint in a one-dimensional space. So what's the midpoint between -3 and 5? And just looking, you can see it's 1. How do we get that using algebra? Well, you just add the 2 points. And divide by 2. So you can actually think of it as an average. So -3 plus 5 divided by 2 is 2 over 2 or 1. Let's do another one. All right, can you find the midpoint between -17 and +23? If I were you, I would hit the pause button and try that one on your own. All right. So we just add the 2 numbers and divide by 2. So -17 and +23 make +6. 6 divided by 2 is 3. All right, that's the midpoint in one dimension. How do we find the midpoint in 2 dimensions? All right, let's find the midpoint in 2 dimensions. So we'll find the midpoint between 2, 1 and 12, 11. Let's draw a line between those 2 points so we can visualize it better. So the midpoint, the point in the middle of these two, will be someplace along this line, halfway. Now let me draw some other lines that'll help you visualize how we're going to find it. So the midpoint between 2, 1 and 12, 11, well, the x-coordinate of the midpoint will be halfway between 2 and 12. So we could just find the midpoint between those two. And the midpoint of the y value is between 1 and 11. So we just find the midpoint of those 2 points. So we just find the midpoint between the x coordinates and the midpoint between the y coordinates, and that'll be our midpoint. And my suggestion is to go ahead and finish it on your own and then check it together. All right, so you're going to have 2 plus 12 over 2 and 1 plus 11 over 2. 2 and 12 make 14 over 2, which is 7. 1 plus 11 is 12, divided by 2 is 6. So the midpoint is x equal to 7, y equal to 6. These lines. It's easy to see that 7 is the midpoint between 2 and 12, and 6 is the midpoint between 1 and 11. All right, let's have you try an example on your own. So can you find the midpoint of -3, -8, and 17, 24? And if I were you, I would hit the pause button and try that on your own. All right, so midpoint, the x-coordinate of the midpoint is just the middle of -3 and 17. So it's -3 plus 17 over 2. And the point halfway between -8 and 24 is the y-coordinate of the midpoint. -3 plus 17 is 14. -8 and 24 is 16. So the midpoint is 7, 8. And a fun thing to do on a Friday night would be plot the 2 points, and you can verify it visually like we did here. All right, to find the distance between 2 points, first let's go back and talk about our old friend Pythagoras, who found the Pythagorean Theorem, the relationship between the lengths of the sides of a right triangle. If you take the square root of both sides, you get C is, and normally you would get plus or minus, but because we're talking about a distance, we only get the positive. And you probably recall that this long side is called the hypotenuse. All right, let's do an example. Let's find the hypotenuse of this right triangle. So we're just going to put 5 squared and 12 squared, which is 25 and 144, which add up to 169, which happens to be a perfect square. So the principal square root of 169 is 13. By the way, if all 3 sides are integers, then those 3 make a Pythagorean triple. Which is a fun thing to Google on a Friday night. All right, how will we use this to find the distance between 2 points? All right, so we want to find the distance between -2, -3, and 6, 12. Well, how can we use the Pythagorean theorem? Well, let's do a little drawing here. So first, we want to make note that we're looking for the length of this line. And if we use these points to draw a triangle, then we can just find this distance here and this distance here and use the Pythagorean theorem to find this, which is the hypotenuse of this rectangle. So remember that we're going to use the Pythagorean theorem. And you want to make a note that we're squaring this distance and squaring this distance. And otherwise, you would have to be very careful to make sure that the difference came out positive. So we're going to take the difference between -2 and 6. So if you subtract -2 from 6, it'll come out positive. If you subtract 6 from -2, it'll come out negative, but it'll be the same number. We won't need to worry about that because once you square it, it'll become positive. Now, if you want, if you're feeling brave, go ahead and hit the pause button and finish it out on your own. All right, so the distance between the 2 points is going to be the square root of the distance between the x values. So that's 6 minus -2. And 12 minus -3. So 6 minus -2 is 8. 12 minus -3 is 15. Eight squared is 64. 15 squared is 225. $64 and 225 make 289, which happens to be a perfect square, so its principal square root is 17. And you're probably freaking out right now thinking, oh, this is another Pythagorean triple, 8, 15, and 17. All right, so again, you don't have to worry which one you subtract first. You just find the difference in the x and square it, which makes it positive, and find the difference in the y. So let's try and write down the formula for the distance between 2 points. So the distance between 2 points is just the principal square root of the difference between the x values squared plus the difference between the y values squared. Why don't you try one on your own? So I would hit the pause button and try this one. All right, and it doesn't matter which one you call x1 and which one you call x2. So just to mix it up. So we have -5 minus 2 squared plus -10 minus 14 squared -5 minus 2 is -7. -10 minus 14 is -24. You'll notice these both came out negative, but that's totally fine because when you square a negative, you get a positive. $49 and 576 make 625, which also happens to be a perfect square. The principal square root of 625 is 25. And you're probably wondering why they used the letter R in this formula. Well, because we're going to use it to find the radius of a circle. So let's draw you a picture. All right, one way to think of a circle is it's all of the points that are an equal distance from a particular point, and that distance is called the radius. All right, so if the radius is the distance from the center to any point on the circle, and we call the center of the circle the point HK, well, how do we find the radius? Well, that's the distance between this point HK and any point on the circle. So the radius is just the principal square root of the distance between the x values and the distance between the y values. So this is just the distance formula that we had before. So we can use this to find the equation of a circle. So if we know the radius of the circle, we know the center of the circle, we can just plug it into this distance formula because the circle is all points whose distance is the same away from a particular point. So our radius is 8. The center is at 2, 3. So it's just going to be x minus 2 squared and y minus 3 squared. And you can leave it like that, or some people like to square both sides. Either way is totally fine. Let's do another example. All right, let's find the equation of the circle whose center is at -3, 4, whose radius is 5. And if I were you, I would hit pause and try it on your own. All right. So we're just going to put those parameters into this distance formula. So the radius is 5. And we have x minus -3, so that just comes out to x plus 3. And y minus 4. And that's all you have to do. All right, before we do the next section, let's review our friend, the perfect square trinomial, which comes from taking a binomial and squaring it. So we get x squared plus 5x plus 5x plus 25. X minus 3 squared is x minus 3 times x minus 3. That's x squared minus 6x plus 9, x plus 7 squared. Is x squared plus 14x plus, 49. So all of these have the form, you have x plus a squared, you get x squared plus 2ax plus a squared. So you probably recall the super fun activity called completing the square, where you're given the first 2 terms of a perfect square trinomial, and you have to find the third. So you just take half of the middle term and square it. So what would complete this square? X squared plus 8x. Well, half of 8 is 4. 4 squared is 16. If I were you, I would try to complete those other 2 squares on your own. All right, so you take half of the middle term, which is -5. You square that and you get 25. Half of the middle term here is 6. Square that and you get 36. So that's how you make a perfect square trinomial. Why are we talking about that? Let's find out. All right, so first let's go back here. This is our equation of a circle whose center is at H and K. And another way of writing this is if you square both sides. So let's take a look at this. So suppose you're given the equation of a circle that looks like this, and we want to find the center and the radius. So our goal is to rewrite it like this. So basically, you're going to take these first two parts, and you're going to complete the square for those two and make perfect square trinomials for this and this. And if you're feeling ready, you could go ahead and hit the pause button now and try it on your own. So we have x squared minus 2x. You take half of the middle, which is -1, and square it, and you get +1. Now this is an equation, so we have to add that 1 to both sides. And then we complete this square. So we take half of the middle here, which is -2, and then square it, which is +4. And because we have an equation, we're going to add that to both sides. So now we have a perfect square trinomial here and a perfect square trinomial here. So we'll write those as a binomial squared. So this is going to be x minus 1 squared plus y minus 2 squared equals 10. So the center is at 1, 2, and the radius, well, 10 is r squared, so r is going to be the principal square root of 10. Let's try another one. All right, let's find the center and the radius of the circle. So again, I wrote down our goal. You want to write it in this form. If I were you, I would hit the pause button and try that one on your own. All right, so all we need to do is complete the square here and here. We take half of the middle term, which is -3, and then square it. -3 squared is 9. Make sure you add it to both sides. And then we complete this square. Half of the middle term here is 5. Square it, that makes 25. Make sure you add it to both sides. All right, 3 and 9 and 25 make 37. And we take our perfect square trinomial and write it as a binomial squared. So it's just going to be x minus 3 squared. And then rewrite this perfect square trinomial as a binomial. That's y plus 5 squared. So the center is at h and k. So x minus h. So the center is going to be positive 3 and negative 5, because that's y minus negative 5. And this is the radius squared. So the radius is going to be the principal square root of 37.